Good evening. Today is Monday, November the 16th. I'm doing these videos tonight because I wasn't able to get them done today at school. But in pre-calculus today, we looked at the graphing of other trig functions besides the sine and the cosine. So what I'll do is I'll show you how to go from the sine function to the cosecant function. And then also we'll look at the tangent function and the cotangent function. So I'll go ahead and share my screen here. Now we'll set up our axis here. So we've got our vertical axis. We've got our horizontal axis. And then you remember we've got if we draw our sine curve and our cosine curve, we kind of come across here with these kind of dashed lines across here, so we can tell where our amplitude is, like this, and then like this, and like this, and so forth. So that's our y equals 1, and then here's our y equals minus 1. So we come across these should be, if I could dash this line, it'd be a whole lot easier. But anyway, so, and when we look, if we do our sine curve, remember we mark off our 2 pi point, which would be here. And we mark off half of it, which would be pi. So this would be pi. I'll put it up here so it'll be out of the way. And then we do the same thing. So we mark our 3/4 and our 1/4 point. And then we come back over here and we do the same thing. On the negative side, we got our minus 2 pi. And then we got our minus pi. And then we've got our minus 3 pi over 2 and our minus, I want to do that. So we got our minus 3 pi over 2 here, and our minus pi over 2 here. Now, if you look at, so let's come up here and let's make this a different color, okay? So we're going to do the sine curve, sine x, y equals sine x. Now, so if you remember, if you go back to your unit circle, the sine is the y coordinate. So at 0, the y coordinate is 0. At pi over 2, the y coordinate is 1. At pi, the y coordinate is back to 0. At 3 pi over 2, it's down to minus 1. And then at 2 pi, it's back at 0. So if I draw that part of the curve, it's a smooth curve. It comes up like this, and it goes down like this, and it comes down and comes back up to 0. Now, if I go in the negative directions, minus pi over 2 is here. That's the bottom of the circle, which is 0. Minus pi is to the left side of the circle. Once again, that's minus 1. This is 0. And then at minus 3 pi over 2, which is the same thing as pi over 2, so that's positive. And then we go back to minus 2 pi, which is here. So this part of the curve is the same as the other part, except it just mirrors it, right? Now, so what we're going to do here, remember, let's get us a different color here. Let's see, we can do blue might be a good color. So we can do y equals the cosecant, which is the reciprocal of the sine curves. And when I always draw the cosecant curve, I always do it just like this. I draw the sine curve, and then I do the reciprocal. So when you're doing a reciprocal, if you think about it, if I have 0 as a y value, 1 over 0 is undefined. So I'm going to put myself a vertical asymptote right here. Everywhere I have a 0, I have a vertical asymptote. So everywhere I have a 0, I have vertical asymptote. So I have a vertical asymptote right here. And then I have a vertical asymptote here at 0. And I have a vertical asymptote here at minus pi. And I have a vertical asymptote here at minus 2 pi. Now, if you think about reciprocals, so if I have a 1 over 1 is 1. So that doesn't move. That point stays the same. 1 over 1 here stays the same. This is minus 1. So 1 over minus 1 stays minus 1. So I have the thing here. Now, and if you think as the original curve gets smaller here, as we move x back towards 0, as the original curve gets smaller, 1 over a small number is a big number, so the reciprocal curve goes in the opposite direction. So it would go up like this. Over here to the right, as the original curve gets smaller, the reciprocal curve gets bigger. So it goes like that. Now over here, the original curve gets smaller in the negative toward 0. So the reciprocal would go down. And then here, same thing, it would go down. So for the layperson's definition, if the original curve smiles, as you see here, then the reciprocal curve is going to frown. So it's going to come up like this. And if the original curve frowns, then the reciprocal is going to smile. So that's the way you go from the sine curve to the cosecant curve. Now, if you look, if we go back to the sine curve here, remember the domain and the range. The domain for the sine curve is all reals, right? So it's all reals. So I got my real number symbol here. And the domain, the range is from -1 to 1, like this. Now, if I look at my cosecant curve, now notice, say my cosecant curve, if I come down here, if I do my domain, it's a set of reals, but every pi starting at 0, see, so I have x not equal to 0 plus k pi. Now, anytime you see the expression k pi, k is an integer, right? Like it can be 1. If it's 1, I'm sitting here at this undefined point. If it's 2, I'm here. If it's -1, I'm here. If it's -2, I'm here. If it's 0, I'm here, and so forth. So, and your range here now, notice your range, see, whereas the sine function is constricted from -1 to 1, the cosecant curve is y less than or equal to -1 or y greater than or equal to 1. Okay, so you got this hole in the middle of it. Now, we can talk about adjusting with the amplitude and move back and forth and shift the thing sideways or add numbers to the end and move it up and down. All those transformations that we did with the sine and cosine curve, we can still do with the cosecant and the secant curve, okay? Now, so I'll leave the secant curve to you because you do the same thing. You first draw your cosine curve and then you do your reciprocal to get to the secant curve. So now what I'm going to do now, I will erase this. And once again, if you're not ready to go away from this, you can stop it and pause the video and look at it or go back. But I'm going to go ahead and erase here. And when I erase, what I'll do is I'll go back in, I'll look at the tangent now, because the tangent is the other thing we looked at, the tangent and the cotangent. It might take me all day to get this thing erased. I think, let's see if I can do around like this and do, nope, it doesn't work. Sometimes it works where you can just kind of circle the thing and erase it. But anyway, so here we go, right? All right, so now, so the next thing I want to do, we'll draw our axis again, because what I want to do is I want to draw the tangent function. See, we haven't looked at the tangent function here. Let me undo that and go back in, get my original color. So here's my X, and here's my Y. Now I'm gonna put my same marks, but notice I'm not going to put a vertical mark. So you see, here's my minus 2. I mean, this is my 2 pi. So I can go halfway in between, and this is going to be pi. And then I'm going to mark this as pi over 2, and this is 3 pi over 2. And then I come back over here and do the same thing. So I got a minus 2 pi, and I have a minus pi here. And I have my minus pi over 2 and my minus 3 pi over 2. Now here, if you go back and look for the tangent function, so now we're going to draw the tangent function. So we'll do y equals tangent x. Now, if you think about what you know about the tangent function is the sine over the cosine, right? So at 0, your sine is 0 and your cosine is 1. So 0 over 1 is 0. So you got a point right there. Now, at pi over 2, which is at the top of the circle, your sine is 1 and your cosine is 0. So 1 over 0 is undefined. So here at the pi over 2 point, for the tangent graph, you have a vertical asymptote. And if you think about what happens, say as you go around the circle at pi, you have sine 0, cosine minus 1, so that's a 0 point. And then at 3 pi over 2, you have a minus 1 for the sine and a 0 for the cosine. So once again, you are undefined. So we're going to have this undefined vertical asymptote here. And then, of course, when you get back around to 2 pi, it's the same as what you had here at 0. So this is a 0 point. Now, if you go to the left, minus pi over 2 is the bottom of the circle, so it's the same as we had over here. So that's another vertical asymptote. So you're coming down like this, and you're going down, down, down. And at minus pi, you're at 0 for sine and minus 1 for cosine, so that's a 0. And at minus 3 pi over 2, which is at the top of the circle, you're at 1 for sine and 0 for cosine, so that's another vertical asymptote. And then, of course, at minus 2 pi, you're back at 0. Now, so the thing you can look at here, so with this so far, all we have is just vertical asymptotes and 0 points. But if you remember, halfway between 0 and pi over 2 is pi over 4, which is right about here. And right about here is minus pi over 4. And at pi over 4, the tangent is 1. And at minus pi over 4, the tangent is minus 1. Now, if I come over here and draw the circle over here, let's draw our circle over here, our unit circle. And if you look at a given point, see, here's my angle. And this is the X is here, and the Y is here. So now, if you kind of visualize what happens, as this point goes from here up like this, the y gets bigger and the x gets smaller. So the tangent gets bigger. It's 1 there. As you go back down this way, it would get smaller. So we have a function that basically it starts here. It's going to start down here at this asymptote. It's going to come up. It's going to go through this point right here, and it's going to go through 0, and it's going to go through this point, and then it's going to go and keep climbing all the way to, now remember, when you get to pi over 2 up here, when you get to pi over 2, the sign is, the tangent's undefined, but right before you get to pi over 2, the tangent is infinite, okay? So now if you look at what happens here, so the same thing applies over here because this is second quadrant, tangent's negative, third quadrant, tangent's positive, so now we're coming up like this. And in the fourth quadrant over here, we're back to tangent being negative again. So the thing about the tangent curve that we didn't see in the sine and cosine curve is the tangent curve has a period of pi. Period is pi. The sine and cosine curve had a period of 2 pi. Okay, so let's finish this up here. So this comes up like this, it goes through like this and up, okay? And then we have the part over here that looks like that, okay? Now, so that's what the tangent curve looks like. Now, the domain, once again, it's similar. The domain here, the range is all reals, right? Because the range of the tangent curve, it goes from minus infinity to plus infinity. So the range is all reals. The domain is the reals x not equal to, notice here, see, it starts being at pi over 2. So it's pi over 2 plus k pi, right? Because you lose a point every pi, but it doesn't start at 0. It starts at pi over 2. So now that's the situation with the tangent curve. Now we're going to do the same thing here. If we come over here and look, we'll do the same thing here with the cotangent curve that we did with the tangent curve. So since the cotangent is the reciprocal, everywhere you have a 0 on the tangent curve, you have an asymptote on the cotangent curve. So we're going to come down like this, right here. Here at 0, we're going to have a vertical asymptote like this. And over here at 2 pi, we have a vertical asymptote. Okay, over here at pi, minus pi, we have a vertical asymptote. And over here at minus 2 pi, we have a vertical asymptote. Now, the thing we haven't seen or we didn't see in the sine and cosine going to the cosecant and secant, we didn't have asymptotes. But if you think about an asymptote being 1 over 0, if you invert 1 over 0, you get 0 over 1. So everywhere you have an asymptote here in the tangent curve, you have a 0 point for the cotangent curve. So you got 0 there, you got 0 there. Now all these 1 points, see the 1 points stay 1, so we got 1s across here, 1s like that, 1s like that, and the minus 1s stay minus 1, they don't change. See? So now if you kind of look at what happens here, as the tangent curve goes up, the cotangent curve comes down. As the tangent curve comes down, the cotangent curve goes up. So, and we come across here now, as the tangent curve comes up, this one goes down, and it keeps going down like this. So what you see here is we have a very similar curve. It kind of bends around and goes like this. And then it comes down off of infinity. It bends through here. It goes through here. And it goes down like this. And this one, it goes down and down and down. Now, it doesn't cross these asymptotes, okay? So what you can see now is the range is the same. The range is reals. The domain is similar, but instead of having pi over 2 plus k pi, it's just k pi. Okay, so these are the things that we looked at in class today. We spent some time, a little bit of time trying to adjust them sideways, but for the most part, this is what we did. So look at your homework assignments. If you have any questions, send me an email, and I'll get back to you on it. So I'll stop sharing now, and I'll see you tomorrow.